Right, what you're going to get from me in about an hour and a half, and it seems much longer, is the Internet of Things, MQTT, Message Queue Transport Protocol, Azure IoT Hub, building chatbots, and how to make a robot that can carry cheese. And in the halftime break, you can actually have a go at the robot contact sport that I'm presently working on, which is called the Robot Rumble. And if this isn't wonderful, I don't know what is. Indeed, I do not. So, okay, we're going to talk about building a robot, the thing I've made called Hullos, which is an embedded robot operating system, making a robot with 2 brains, Azure IoT. By the way, it'll all make sense at the end, and we'll sing a song and I'll go home happy. And you can tell people that you were there, and they won't be impressed at all. So there you go. First, a word about me. Tall. There you are. This is kind of the flavor you're going to get, okay? It doesn't actually improve on this at any point. This is just, you've got to, after a while, you get to nod and smile. Okay, bit more words. I spent my years at teaching computer science at the University of Hull. For many years, I was in charge of twisting minds and crushing dreams. So I was basically your standard bog standard lecturer. I'm also a Microsoft MVP. And I blog at robmiles.com, and I tweet at robmiles, because I got in early and got the domain name. I'm quite proud of that. And I write books. There's one. Begin to Code with C#, an awesome book. One, yeah. Thanks, Mum. Oh, wonderful. And this one here, yeah, Mum got through, but so did 5 others. I do a Python one as well. If you want to buy, these are books to teach programming from first principles, which just goes to show that I do have principles. And so you can read these, and then you can fail to get demos to work and email me, and it all goes wonderfully like that. So yeah, please rush out and buy my books. That's probably enough of the shameless pluggery. Let's go on to something a bit more technical to do with building a robot. Now, I was at the university for a long time teaching programming, and at the time we were teaching C# and we were using XNA and we were writing games, and it was awesome. People love writing games to learn how to program. It's a great way to learn how to write code, is to actually write games. It's awesome, it's fun. Another good way to do it is to build robots. And when I left the employed university, actually that's LinkedIn's fault. You know how LinkedIn says people send you congratulations for being your current employer for so many years? Well, I got one saying, so-and-so had been there for 38 years. Well done, Rob. And I thought, 38? Yeah. What? So I don't do that anymore, because I wanted to find out what other things I can't do. And here I am again. And so I thought I'll have a go at doing other bits and pieces, writing. I've mentioned I write books. Have you noticed? Anyway, and I thought I'd have a go at building some robots to teach people to program. And so I came up with this thing. This is the all perspex high-speed version of the Hull Pixelbot. It's cheap to make, easy to build, extensible, connectable, and cheap to make. I am from Yorkshire. And proud of this, and the technical definition of a Yorkshireman is a Scotsman who's had generosity beaten out of him. So we're kind of careful with money. I wanted just to see how far you can go with tech to actually encourage people to write programs and do stuff. And I came up with the idea of making a robot. And this is, I started off with the 3D printed ones, which is this chap. In fact, I've got slides about this, so why not show them? Why not show the slides here, Robert? Why not? The idea is that you can print it on a 3D printer. Most of the people I know that have got 3D printers, after a while, they've printed a few things off Thingiverse, and they've done that cubey thing. You can turn bits and pieces, and they get kind of bored after that. So you give them things to do, and I get to print robots for you. So this is quite easy to print. Everything I'm going to show you about it is up on GitHub, so you can download it and play with it. So if you have a printer, you can print the chassis. You just screw the things together with 3mm bolts, and it all just works rather swimmingly. And all the parts are flat. I mean, you could make a robot like this out of a milk carton or anything flat, or any kind of mechanical sort of physical thing you want to use. But I like the shape of these. Had a bit of fun designing them. The actual robot design, this is interesting. Makes a change. The actual design for the robot's a Python program. I tried using Blender. Blender's horrible. My God, it hurts your head. I tried using FreeCAD. I tried using 123 and all those machines. Turns out that I can't do 3D design for toffee. It took me a while to figure out, in 3D design world, Z comes out the floor. Do you know this? In game world, it comes out the screen. And realizing that Took a long time, and it still hurts. You've got width, depth, and height, and it really makes your brain... Anyway, I digress. This is done with a Python program. I found an interface for FreeCAD that lets me write Python code inside my CAD tool. This is all pushed out by a piece of Python code. And I can make circles, I can make rectangles, I can cut them from each other, I can fuse them together, and you can make things with that. And they fall to bits. So this is done with a big piece of Python code, which is kind of funky and interesting. So that's generation 1. This is generation 2. This is the Perspex version. If you have a laser cutters are awesome, okay? 40-watt laser in your garage? Oh yes, please. Not a loud one, rather sadly, but I know a friend who's got one, which is nice, and the company in Hull does them as well. So I got the problem with this guy is, yes, you can laser print, you can 3D print him. Yes, it takes about 9 hours. So that's the trouble. If someone says, great, can I have 30, please, Rob? That's about a month of solid printing for me, which is not great. This guy, there's about an hour's worth of 3D printing for the actual components that hold him together. The rest of it's all Perspex, and that's much nicer to work with. So we've got these guys, and if you want to get a kit of parts, then go to kit.hullpixelbot.com, and I'll let you know how much it costs and when I can get you to have one. I might even make a kit then, who knows. I use a thing called hands up, quick straw poll here. Who likes straw? No, okay, not funny, right, keep moving forwards. How many people have heard of the Arduino? Oh, wonderful. Okay, so you know where I'm coming from on this. Less than a £5. I get the stepper motors that drive the robot for about £1.50 a pop. It has a ring of pixels in the top because it's a Pixelbot, and that's about £1.50. Distance sensor's about 64 pence. Battery holder's about £1. Cables and blah, blah, blah. You can get the bits for around 10 quid on AliExpress. I go there and show you, but it's really expensive for me because it costs me about 20 quid. I always buy something. I'm going, oh, distance, right, laser rangefinders, £6 a pop. I'll have 3 of them. You know, and MP3 players, 87 pence. Okay, I bought 5. I haven't used any of them yet, but I will. I want to have these guys playing the Ride of the Valkyries as they come in for the kill. That's what I want to. That's what I really want to do. So that's all. Yeah, you can go there. This is an awesome site. It really is, and well worth the visit, but hide your credit card, freeze it into a block of ice, whatever. The Uno, I like the Uno. It's kind of like the one that started the Arduino revolution off. It's got loads of pins, you can just plug straight into there. You plug a PC in there to program it. It's not particularly fast, and it's C++ to program it. Now, people keep saying to me, why do you put a Raspberry Pi on this thing instead? Now, the Pi is a lovely device. And the smaller Pis, the Pi Zeros, are great. The thing with the Pi is if you turn it off when it isn't expecting it, it basically can fry the OS, which is not a good thing to do. And the step 1, learn Linux system admin as your first step in learning how to make a robot work, not a great start. So I'm using the Arduino because I basically like the fact you can just write code. And for the price, it is completely awesome. And lots of people know about them and love them. There you go. That is a piece of Arduino code. Written in the Arduino IDE, which is C++. You can get that for the PC, the Mac, Linux machines, and the Raspberry Pi. I don't do that myself because there's a thing called Visual Micro, which, if you haven't heard of it, is really good. If you want to write Arduino code on your PC, it's a Visual Studio plugin, and it's really, really good. And you can use it for free on demo mode or pay them. I think it's 30 quid for the license. And it's such a useful tool. You should pay them the money. It's worth it. It's very, very good. That lets you write the code, deploy it. It even has a debugging stroke tracing element, which I've never managed to make work, but I'm assured is quite good. So take a look at that. The idea is that you write your program in C++, you push it down a serial cable into your Arduino, and the Arduino then runs it when the power comes on. And it's as simple as that. At Hull, we do a thing called Build a Robot in a Day, which the clue's in the name, really. You turn up, and we give you this bag of bits. And then in the morning, you build the robot up. And in the afternoon, you code it up and start putting code in. We've done a couple of these, and local companies send people along that want to get some embedded experience, and they quite like it. Email me at build, build it, Rob. I like that, you know, build. Quite fashionable these days, at hullpixelbot.com. If you want to get involved in that and come to Hull, I'm going to basically, if I get 10 folk together who want to do it, they pay me some money. I've got a room at C4DI where I work now in Hull, and we build a robot in a day, and then we go off and play with it. The problem that I had with this is that it was really, you've got these people who are keen on tech and done a bit of coding, perhaps at fairly high level, and they build a robot, and they love doing that. People like putting this in. I mean, I have a big document that basically takes you through a bit like a Lego kit assembly thing, takes you through it. But the snag was that I then had them writing C++ from a standing start, and that really hurt people's heads. It's a great way to start if you're very, very keen and have an amazing sized brain. If you're like me, then trickier. So what I built was this thing I've called Hullos. I'm very keen on branding things with the place I've come from for some reason, and so it's called Hullos, and it's an embedded robot operating system that I made. It implements an embedded scripting language which is quite fun and runs inside the robot. And now there's several reasons why I wanted to do this. I think the main one was I wanted to see if you can make a meaningful language run in 32K of ROM and 2K of RAM, which is quite an interesting challenge. People these days don't think that memory is an issue. Just put another chip in or whatever, it's so easy. And I like the idea of doing some really constrained coding. So I put Hullos together and sort of set up to see where I'd end up. So a Hullos program looks like this. This is a robot program which will run. We'll put it in the robot and I'll prove it in a minute. It's a comment, avoid obstacles, begin forever, which means just loop forever. Go green at the top, start moving. Get the distance sensor reading into the variable called D. If D is less than 100, turn red, rotate 90, and then go round again. So you've got a robot that will basically do a simple bump and go toy. And that's it. The program inside the Arduino takes that, tokenizes it, and then interprets it. And off we go. The program is stored inside the EEPROM inside the Arduino and runs when the power comes up. And that's it. I've made it a bit like Python, because my theory is if you're pointing this at kids who've done a bit of Python, it ain't a bad place to go. So I'm using indenting to do the actual, I had begins and ends in, hardwired and whatnot, but they got a faff to type. I'm surprised how much I like Python. Having played with C# for about 10 years, I thought that when Python came, it was too silly and dangerous and scary and whatnot. But if you're aware of that when you start writing the code, then you can write awesome stuff in Python and very, very quickly. And so I kind of like this now. We used to have these big arguments when I was back at the uni about anyone here know what the best programming language is? Anyone okay? Fortran, yeah, I remember Fortran, column 72 and all that wonderfulness, and put a small talk. Now,
BBC Basic.
Could be. The best programming language is the one you get paid the most for writing programs in. Okay? If you give me enough money, I will write Visual Basic with a huge smile. I'll even do JavaScript, my goodness. And so, which is the best language, don't care. I want to pay the mortgage every month, and so I go for the language that works. C#'s good for that. Python's very good for that. The other languages have a nice appeal as well. But back to the plot. This is my interpreted language sitting inside my robot. I've got a Python program which I've written, which runs across Pi, PC, Macintosh, Linux box, and there's my program again typed in. This is a glorified terminal program. I'll show you in a second running. And you type the programs in and hit go, but you can just plug it into a serial port and push programs into the robot, and it will understand them and run them. If we actually do that, Hullos takes the programs, semi-compiles them, and interprets them and bangs them in the E² prom. If I look at the actual code that I get from my compiler, this is it. So you've got that, everything is 2-character names, okay? So CL, C stands for command, L stands for label. I'm making a label called L1. P stands for pixel, N stands for color, I think, for some reason, because C are gone. So G means green. Just start moving forward a very long way. Set a variable called D to the distance, compare D with 100 and branch to L3 if it's less than, which is down here somewhere. Otherwise, go red, turn 90, wait for the turn to complete. There's my label to jump round this thing. There's my jump to go back to the top, and there's my jump so I can put brakes in here. Now that is like assembler code for a language you've invented which you're semi-compiling, and it's all powered by switch statements. There is absolutely no magic inside the thing. I'm really keen to be able to show people that when you write something like C# or Python or whatever, there is no magic that takes that code and makes it work on your hardware. It's all just fairly mechanical stuff. And so this is effectively the stuff, and that's all it does. This is about like a breakdown of the whole thing. Oh, by the way, I'll put these slides up on robmiles.com so you can download and take a look at them. So this is just sort of nothing magical at all. And I'm really keen on that. I don't want people to be looking at what I've done and thinking it's magic. I don't want people to think that compilers are magic. Everyone should write at least one kind of compiler in their life. It's a giggle. It's a nice thing to do. And the nice thing about this too is that if someone comes along and says, why can't it read a temperature sensor? I want to do that with your language. Right, fine. Well, just add it. Go into the runtime language and add a thing that implements that. Then go into the compiler and make a keyword for it and push that back to make the call through. And you've done it. And so it's designed to be very, very extensible. This is actually the grammar. I found this thing on the interweb that takes a bunch of grammar and makes these nice diagrams. When I learned how JSON worked, have you ever seen the JSON spec? With the little lines and the things and the loops. And in a single page, they can tell you exactly how the language works and how it expresses what you want to do. I love that. So I found a sort of a railroad diagram producer for my language, and that's up there as well to show you how the thing works. There's even a command called angry and a command called happy. So you can make your robot angry and you can make him happy if you want to do that. You can also make him move, turn, perform arcs, delay, play sounds, use variables, and you've got if, while, and forever to do your decisions. And that's how it all works, fits together. So let's do some demos. Enough of this talk. Let's pick a random robot. I'll have you. Wonderful. And I'll take him over here. It now wakes up, it looks to the serial ports, finds the thing, and now it's talking to my robot. So now I can start typing in my programs. It's a bit hard to see. I apologize. The font size, it says begin, which is the thing at the top. And if I put the word red in here and I hit run the program, then so send program. There you go. It was red. See? If I want to make it go blue, I can put blue in there, and it'll go red followed by blue. Send the program. It was red followed by blue, but you didn't see the red because it was really quick. So then the kid goes, OK, how do we fix that? Well, we put a delay in here. And hang on, delay of can't type today. Delay of 5, and then we hit run, hit send program, and bang, it goes red, then it goes blue. And everyone, at this point, the whole room is clapping and there's dancing and everybody's really sort of taken away by the whole magic of the thing, most times. And so I've got a button here called random program. No, I don't want to save that. We'll go on there. So there you go. It's my turn and run forever. This is my program that does what we've just seen. So if I hit send program on that one, then my robot now, is he going to work? Oh, if I bring my hand close to him, he goes red, and then goes away. And he's now turning and running. This is called a robot coward. Okay, so I'll show you how it works on the play field. You wouldn't want your robot to do this, but you can if you like. Turn him on battery. Remember the program's in E squared prom, so I bring my hand up to him, and he goes, ah! And he turns around and he runs away, you see? Very slowly. The motors I'm using are £1.50 a pop, which is nice. They're stepper motors, not servo motors. So I haven't got a lot of speed, but I do have a ton of precision. These guys have got 512 steps per revolution, and it's extremely repeatable movement. So I want to put a pen on the back and start drawing with these things. Because if I make it around in a circle, it goes back to where it came from. It's actually pretty repeatable. I'm quite pleased with them, but they're not very quick. But the thing with quick robots is that they fall off the table quicker. If If it's a fast, it just goes boom and smashes on the floor into millions of pieces. You have to buy another one, which is not good. These guys are a bit easier to catch, which I quite like. And as far as the kids are concerned, the nice thing about the kids is that the fact it does the thing is amazing. And I've seen this with kids who play with the robots. You can give them a massive sort of 3D rendered environment and get them playing with that. And they just go, meh, my PS4 at home does that. If you give them a program they write that makes a light come on or a robot move, they go nuts. They love it. I don't know why this is. I'm really pleased it's the case. But the idea is that you can get your little robot, you can run my little program, you can squirt the programs into the robot. And if I really want to show you how it all fits together, I can do that because I can just plug the robot in. And I'll have to tell my Python program not to notice, but the Python program will probably now notice there's a robot back. So if I now go into here, tell it to use COM1, and then connect to it using a terminal, I can actually talk to the thing directly. Serial monitor, there we go. And I can have a conversation now. I can now basically say, version R, this is the version of the Pixelbots, and if I go star IP, that means show me your program, then there's the program. That's actually the stuff that you've seen made by the stuff. I could bore you even further by showing you the actual code inside the C#, the C++ that does the compilation. But it's no magic. It's just a bunch of switch statements and a bunch of looking for strings in strings kind of things. It's all out there to look at and throw rocks at. And I'm actually quite pleased with that. So we'll keep on moving. My line is these days, as long as I'm happy, everything in the garden is wonderful. So we've got this embedded OS. The thing about Hull, which I do find interesting and intriguing, is that I'm using it to control silly robots. There's no reason why you couldn't make it do anything else. You could make it control cat flaps or machines or whatever, and you could increase the number of sensors too. That's also quite easy to do. So there's nothing particularly magical going on here, and it should be fairly sensible. I just did it really to see what's what. It's nothing to do with carrying cheese just yet, but we'll keep moving forward. Because what happens now is it gets really interesting. I've got my robot that can take serial messages and do things with them. What I want to do now is hang it off the internet. So I have myself a network co-pro, and I now have a robot with 2 brains. Oh. It's quite good because this brain here costs £2.50, and this brain here costs £1. Okay, this is a version of the Arduino called the Pro Mini, which is just like the big one, only much smaller. The only slight faff with it is to program it. You have to put a programmer on here, but the programmer costs about £1.50, so it's not particularly expensive to do that. And the idea is that you would solder this into a device that you were building to make our Arduino power, but it's the same device, all the same pins, same IDE, everything else. So this guy handles the motors, and this guy handles the I/O and whatnot, and this guy handles the internet. And this is a guy called, anyone here heard of the ESP8266? Oh, 1 or 2, okay. If you know about the Arduino is quite a funky device. And you can make some quite nice embedded stuff, but IoT, Internet of Things, it can't do without a lot of messing around. But this chap can do everything the Arduino can do, pretty much, plus Wi-Fi. The ESP8266, it gives you Wi-Fi client, which you can hang off a serial port to connect to. You can program it in C++, just like the Arduino, same IDE. You can make it into an access point and a freaking web server. It's crackers. You've got this chip the size of a postage stamp that costs £2.25, and it's a web server. And you can hang it on your home network and use MDNS, the embedded DNS, or Bonjour, as Apple call it. And you can find this thing and hit it up and get HTML back from it, or even images if you put this on an internal file store. It's a stunning device. And there's lots of stuff out there. It supports UDP, TCP, MDNS, and you can use it for all kinds of wonderful stuff. I'm using it to talk a protocol called MQTT, which stands for Message Queue Telemetry Transport. And it's an IBM thing that they invented to actually do small device interfacing, which seems to be a kind of standard. I don't have a big argument about how good MQTT is because it's not that great, but it's very popular and lots of things supported. I mean, you can get MQTT on your Pi. You can put systems on there, or you can use the Azure one I'm going to use in a minute. But this is a really, really nice device. And I use a thing called the WeMOS platform, which is these little chips. That's the actual ESP device, and then they put it on a carrier for you with a power supply and a few other bits and bobs and a programming interface, and then away you go. And I would strongly advise you to have a play with this device, because I find it's really interesting. There's now an ESP32, which is a better version of this, just around the same price. That adds a dual-core processor, and it also adds Bluetooth BLE as well. So you've basically got all the bases covered. You can make all kinds of great stuff with that. And so yeah, MQTT, it's a way of linking sensors to endpoints. So effectively, you've got your sensor somewhere. You can bind that to a server endpoint somewhere, which you can then push messages to. You can run it over serial or Wi-Fi. Very simple packet structure. It runs on the ESP8266, and people I know use this for things like, I've got an oil tank in the shed or whatever, and I've measured the height of the oil in there. So I get my ESP, I put one of these distance sensors on the end, and hey, wow, I've now got I can put temperature. Another person at our hardware club in Hull, he's done quite a fun thing. He's taken a ESP device and he's got the inlet and the outlet pipe to his central heating system. He's measuring the temperature on both of those to see how well his heating's working, which is kind of funky. It's a nice device. If you want to actually connect it to your Azure IoT Hub, then I'm using a thing called PubSub Client, which you can download from GitHub. I modified it to make it work with Azure. Azure uses secure sockets. A different port number has big packets, but you can fix that. This guy here did a post about it, which is well worth a look. There are some walkthroughs on Microsoft sites showing you how to do this as well. I've no idea whether they work or not, but mine does. Okay, so mine is good. And the IoT Hub will take these messages and surface them in your code. I'm basically pushing messages down from the server into my robot. So I effectively on my web end, I can take messages and push them down into the robot to tell it to do things. That's kind of how it works. As far as the WeMOS is concerned, this is the C that runs inside the WeMOS that tells it what to do. So we've basically got, well, step back a little, Robert. Thank you. The Arduino architecture is kind of interesting, because when you write programs that run in the Arduino, you find you have two methods which are inside your solution. One of them is called setup, and it's called once by the Arduino framework when your program starts running. And that's the method which actually configures your hardware, tells it what ports you've got, loads things up. And then the second part of your application is a method called loop, which is called repeatedly to do whatever your program needs to do. So in my robot, setup sets up all the hardware, distance sensors, speaker, everything else. And then my loop method is basically takes a line in my program and interprets it, and then waits a little while, and then goes back and gets another one. That's my loop inside there. At the same time, it's actually checking the keyboard buffer to see if anything's been typed in, so it can actually act on commands as well. But this is the setup behavior inside my WeMOS, and it's, 5 lines of code. Turn my serial port on, set up the Wi-Fi, link up to the robot, set my server to MQTT server 8883, and then set the callback method to a method called callback. And so what's going to happen is whenever I get a message from Azure, my callback function will run. And that's the code that sets things up. This is the code that actually connects you to the MQTT service. It gets a bit funky here because you have to put in some big magic strings. But the idea is that I try and connect. This is how I link my Red Robot. So Red Robot is the name of the device that Azure has got. Oh, that's a duff quote. Oh, I hate it when people do that in presentations. That's very unprofessional. There's one there too. Well, that's not good. Anyway, moving on. This is my endpoint in my service. This is my signature string, which I have to create at the server end to effectively authenticate my robot. So the idea is it's sitting on the cloud. It's using secure sockets, using HTTPS. So people can't really see this. No one's going to figure out what that is, hopefully. And so that is how I connect and authenticate. And then I set my endpoints up, and away I go. And once that's done and running, when the Azure server says something, my method runs to receive it and process it. And what happens inside my little robots, these guys here, is that if you look at this guy, this is Crystal Maisie, because she's made out of blue crystal, which I quite. All the robots have got names. The kids like having robots that have got names. So this guy here is Lady Limebody, which is I ran out of lime filament before. But she's got alloy wheels, which is quite cute. So that's her. And this is Crystal Maisie. But anyway, she has an old style Arduino and a carrier board and the WeMOS on top. And what's happening is that effectively the WeMOS device is sitting on top of the Azure connection, and when a message comes down from Azure, it just pushes it straight into the Arduino to tell it what to do, and that's it. So I've got Hull running underneath, and this thing is transparent. There's nothing clever happening at the WeMOS level at the moment. It's technically possible to run the whole thing inside the WeMOS, but WeMOS only has about 10 pins, not enough to drive the motors. And the snag with the WeMOS is if you make it do hard things, it falls off the network, because this version has a single. So you can do things, but you have to be careful about timing sometimes. But I digress. It's all sitting there, and it's all working. And I've lost my mouse. There we go. Right. So this is my callback message, and this is inside the Arduino now. So when I get my callback, I just take my message from the payload, build it into a string, and then send it to the robot. And that's the code inside the WeMOS that's basically linking Crystal Maisie to the interweb. And it's as simple as that. The IoT Hub, anyone here built an IoT Hub on Azure? It's really easy. It's like mouse clicks. This thing, I give it an endpoint. I then start adding devices. You can use other platforms if you like, but I'm a Microsoft MVP, so I have to mention this one first. Moving on. You get a thing called Device Explorer. I configured this guy with the endpoint address of the Azure platform. And this is a program you can download from GitHub in source form and play with. This is how I figured out how a lot of it worked. So I can go into here, I can basically go into here and I can say, okay, let's pick a robot, Crystal Maisie. Where is she? She's down here somewhere. She's called Blue Crystal here. That's it, gotcha. And I can then actually type in some message to device. Here we go. Better that one. Start again. Blue Crystal. Let's send it the command red, and we hit send. And without further ado, the robot turns red. Now that is just awesome. Thank you. So this is a program you can get hold of and play with. I actually made the other parts of the Azure framework that I've connected to the robots using the code I pulled out of here and fiddled with. But the idea is that this is also a provisioning API as well. So if I go into here, if I want to make myself a new robot, then I would go into here and I go management and I go create and I give it a new, let's go just call it demo robot. And then hit create. And that will now appear inside here. And so demo robot is down here, there he is. And so he's now got a primary key and a secondary key. And if I go into SAS tokens and I go find demo robot, there he is. I can then say, give me a token that will last 365 days, hit generate. Now this thing here, this SR blah, 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 is what was inside the little piece of program that I showed you inside the WeMOS device. That's the binding. Now, if you have 10,000 devices, this will be a very, very painful way to do it. But what you can do is this is programmatic. So if you wanted to make large numbers of devices and produce lots of SAS keys and then push them into your production to actually drop those into E² prom inside the robot, that will be easy to do. So you can scale this up to large numbers of sensors. I'm doing it by hand for just the few that I've got because it works very well for me. So that's how you do it. And if I now hit done, then I've got a demo robot. I think can I delete you? I guess I better really. Let's delete you. Yeah, go away. I can remove it as well. Yep, Okay, so this is the Explorer program which I use, and that works quite nicely. That's how I got started doing this. In terms of the actual code that does it, again, this is very simple. These service client things, you make one of those, you then basically create a message, you give it an ID, you use ASCII encoding because these things only understand 8-bit characters, which is absolutely fine by me. You just call send async on the thing, then close it, and 'tis done. So that's the code inside my programs that let me edit Pixelbot stuff for pushing to robots and whatnot. It's like this, nothing to it. So what I'm hoping is you're sitting here thinking, I could spend 10 quid on some bits and pieces. I could put them in my PC. I could get myself a bit of Azure space or whatever. I could start making remotely sensors that I can connect to remotely. And I really hope you do that. That's kind of why I'm here, because this is dead easy. And it's kind of cool. It still seems magical. I mean, the thing that is, of course, the case, if I send Crystal Maisie to Australia, as long as she can find a Wi-Fi access point, then I can control her. This would work wherever she is in the world because it's running over Wi-Fi. It's not like Bluetooth or anything short range. This is pucker, full on, all the way kind of stuff. And it works extremely well. Very nice. So yeah, you've just seen lots of demo too, actually, because I've actually just done that for you. So what I'll do now is we'll keep on trucking. How are we doing for time? We're doing all right. Has the pizza turned up yet? We all right? Okay. Right, fine. Okay, in that case, now I'll keep on going. At this point, I'll get some more robots out and wake them all up. The way the robot works is that it effectively, it wakes up and looks for an access point. It's got a lump of data in the E-squared prom that tells it whereabouts the access points are, and it will then scan through. These devices are all hanging off my Apple phone at the moment, but they seem to work quite well. When they go green, that means they're happy, so you're happy, and you're going to be happy, and you're going to be happy, please. There you go, one more, then agree. They're all online now, fantastic. So what you can do now is control them from the web. Because I had this idea for a sort of like robot rumble game, okay? Before I go any further, I'm pretty rubbish at writing ASP applications, okay? I've done 2, and this is the second one, okay? And it's basically the template which has been hand tampered by an idiot. And because I never did webby stuff, and I'm still not very good at it. So apologies, but here's how it works. You type your program in, you hit send the program to the robot, and it whacks it into the robot. You hit run the robot, and it runs the program. You hit stop the robot, and the robot stops. And all that's happening is my web page is taking the stuff I'm typing in, and it's pushing it down using the UI that you've already seen. Okay, so this is actually quite funky, and you can actually have a go at this because, yeah, there you go. This is my event management stuff, which is a right old mess. If I go on to my browser, which I'm hoping is still working, here we go. Turn the mouse on. The address you want to hit, folks, is hpb.host. And if you go there, then this is, again, like I said, my web skills are not strong. Okay, I've got a 2-page redirect. Robot Rumble is the top one, and then the quiz, which we'll do at the end, is the last one. That's when we do the cheese race at the end. And so if I hit the Robot Rumble site, then here we go. Click to get started. What should I call myself? I will grab a robot. I will call myself. Been fairly heavily tested. This, as you can see, Rob Miles on Flickr. Ugh. Okay, Jim. I'll use Jim. Hit enter, and it goes rattle, 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 bang. Thud, 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 thud. Okay, so this is I'm controlling Lady Linebody, which is this one here. Okay, and so I can now type in my program. Don't forget, I might change the design of the language to get rid of the beginning and the end. They're there because if you do the indenting thing to mark the end of your blocks, you have to know when the program really ends, because then you can close things off and put your loop things in. And so I added begin and end. It's occurred to me after I did that they're just wrappers for transmission of the code, not part of the code itself. So these might disappear, but This is one of the things about making your own language. You learn stuff. And in here I can go something like, I don't know, move 100, turn 90, no, turn 180. Let's do like a century, turn 180, and then move 100 again. So now if I hit run the robot, you watch the lady line, Bobby, come on girl, come on, you can do it. She goes, do, and then she turns around, and she comes back. That's a bit more than 180, dear. You're wearing your big wheels. Someone's taken over the black robot. Jolly good. If you get onto hpb.host and follow links, there's 2 more robots up for grabs, these guys here. So by all means, have a crack. See, what I thought about doing, but I've never actually done it because no one seems to want to, is I want to do this robot rumble, okay? And the idea is that you have 2 teams of robot drivers, that's quite sweet, and you have 1 minute of coding and 2 minutes of running, and 30 seconds of running. Get it right, Rob. And then one team's going that way as far as it can, the other team's going that way as far as it can. And you do 4 rounds of that and then see where you end up. And I thought this would be kind of like a funky thing to try and do. So I showed some kids it and they went, meh. Which, I mean, what I have discovered, which is something I'm going to have to work on, is that the UI for typing in programs on mobile phones is very sucky. Typing in code from a mobile phone keyboard is horrible, horrible, horrible. Now, if you're teaching kids to program, then you've probably... Are they trying to mate now? Stop it. Just get away, get away, get away. I've looked at things like Scratch, and I think Scratch is absolutely awesome. But the problem with Scratch is that it doesn't take you anywhere that makes you into a programmer afterwards. You can drag and drop and make things that look a bit like code. But for me, I like telling stories in code using proper text. So I'm going to have to try and figure out a nice way of doing some kind of smart editor which has really good IntelliSense that pops these things up. That's in the future a lot more fun. But you can have a go at, if you want to have a go at making your robots work, hpb.host, go to the Rumble site, and then see if you can find one, and by all means come and have a twiddle with that. And I would really like to get 4 people to sort of try and do the Rumble thing, because I think it could be kind of interesting. The language is actually quite advanced, and I've got a cheat sheet, and I've also got some big, thick descriptions of the entire language here. You can make it play sounds. Oh, yes, you can. And there's a full Hull spec there. Can have a play with it later. It's been quite fun to make. And you can just keep on fertling with it. It doesn't harm. This is why we have the wall around the thing. But yeah, the distance sensor works and everything else. So that's fine. But I also talked about chatbots. So let's talk about chatbots for a while. Anyone here build a chatbot? Oh, good. Okay, well. Okay, so correct me when I'm wrong. People get a bit tied in knots about what a chatbot is. Is it a thing you want to have a long conversation with about the meaning of life and stuff like that? Answer no. I want to book a haircut, as you can probably tell. I could really do to book a haircut really quickly. It's that kind of context. So in the context of the chatbot that I'm talking about, we're looking at a thing that will help you do a simple task really easily. Through the maximum possible number of channels. And so don't think about a thing which does all kinds of clever reasoning on what you type in and figures out what you really mean and does that. Think of a thing with a button marked book haircut, and then 5 more buttons marked Monday, Tuesday, Wednesday, Thursday, Friday, and then 5 more buttons marked morning, afternoon, whenever. Bang, 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 bang. Because that's what folk want. If that works via Skype, okay, that's lovely. You could make somebody a hairdresser app and sell it, or make it free, but nobody would download the hairdresser app. No one would do that at all. But if you send them the address of a Skype end, if you give them a Skype contact number, then they can call that and book the haircut through Skype. Everyone's got Skype, everyone makes phone calls, okay? So keep the thing down, bots must be helpful rather than human, and they can have buttons. You can make them vaguely human if you like, but I think I'm more concerned with getting my haircut booked, not talking about, I don't know, anything else really. So, yeah, as far as we're concerned, the bot just takes something in, does something with it, and pushes it out. They're a bit like wizards, and there's no need to go as far as natural language. I've done a lot of good stuff just using regular expressions. The context is actually the key to making a good bot. So I want you to walk away from this session thinking about, oh, I could do some embedded. Oh, I could have a go at that. And I'd like you to start thinking, oh, I could build a bot. I've got people ring me up, and 60% of them, maybe even more, have simple questions they want answered now, and I have to mess around answering those questions. If I could deal with those folk, bang, that would halve my support effort required. So if you've got 4 or 5 people just doing that kind of stuff, you can get them onto more interesting things by getting a bot to take some of the work away. And so I'm very keen on thinking about using these to actually do stuff. And I thought about making a bot to control a robot, because that seemed like a kind of cool thing to do. That's what I've done. In terms of, there's a thing called LUIS, language understanding, which is quite funky, and that talks about intent and all kinds of other wonderful things, and adds voice control, and you can train it. And you can even make bots that have empathy with their users, so they can tell when you're getting cross and contact a real person and whatnot. But I'm not doing anything like that because I'm very simple. Stop trying to escape. There you go. So here's how it works. Your bot sits inside its web service. It talks to its connector, and then that effectively translates what the bot says into a whole bunch of different possible channels. And so you don't have to do any of this stuff. Once you've made your bot, you can point it at what you like, and away you go. You can write in C# and .NET, which is what I like to do. You can use JavaScript and Node, or make a RESTful API, or whatever. There's a couple of links to get started. That one's a bit long, but never mind. Cut and copy and paste is your friend. And then off you go. So, come on. My starting point, I go online and I pull down the starting project, which is a download from the dev.bot.whatever website. There's no VisX installer, which is rather sad, but you get the project template from GitHub, you put it in your templates folder, and then you can make a new project, and it looks like this. So it's just a project type in Visual Studio, and if you've done that, then you're in business. It looks like an ASP page, which is fair enough, an endpoint and controllers. The idea is that our code runs when we get a message from the user, and then we actually respond to that and then send something back. Hey, what are you two doing now? Put it down. Someone's having fun, which is always good. And the program response is rendered by the user interface. So the idea is that they basically take what you send them and then act on it. So at this point, it gets a bit confusing because the icon changes. I'm not quite sure why. It took me a while to find out. The first version of the bot framework actually used a separate service to do this, but then they made it onto an Azure thing. So you go on there, and on the Azure portal, you'll make yourself one of these things, and off you go. And you configure it with a whole bunch of bits and pieces, and start making your host up, and then off you go. You can do this on other servers. All the bot framework code is, again, downloadable from GitHub. You can put it on whatever you like, but I'm again using Azure because it works for me and I quite like it. So there you go. Now, the key to making your bot actually stop doing that. Making your bot actually work is once you've got I've made a Hull Pixelbot bot and given it the name Hull Pixelbot and blah, 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 blah. And then there is the manage keyword. Now, it takes you a while to find this, or it did me, but you hit that, then you can go in and you can set your app ID and your app password, which are 2 stonking great big magic numbers that will bind your application to the bot inside the framework. And once you've got those, they go in the web.config file, and then away you go. And you can run your bot locally without this setup, but you can't see it from anywhere else in the world. At this point, you can chat with your bot. And there's a thing called the bot emulator, which is basically an endpoint which you can talk to with. This is talking to my quiz. And if you go onto the second link of the portal at the moment, you will find the quiz not active message coming back because I haven't turned it on yet. So the idea is that you can test it on your PC and fiddle with it and whatnot using this program. and then after a while you can deploy the thing using Azure and then put it in the wild for folk to hit against. I've got mine talking direct line, Skype, web chat, and those are the 3 channels I've picked. There are lots of other ones you can use. You can use Slack and other things as well. And so yeah, it was kind of easy to do. Look at the code. This gets called when someone types a message to my bot. And I look and I say, oh, okay, what kind of message are you then? And if it's a sort of standard message, then we fire up the root dialog and send that the message that's been sent. Okay. Otherwise, we deal with system ones. I'm going to talk about standard messages, so that gets hit, which is this code here, turns out. And this doesn't do a lot. This is the demo one you get if you build an empty project. This basically takes the string, figures out how long it is, and then says, you sent this text, which is so many characters long, which doesn't impress people for very long, in my experience. What you do next, of course, is you do what I do. This is the code that runs inside my quiz robot controller bot. It goes off and sets the event up, and then I'm using these wonderful things called, anyone here heard of adaptive cards? They're the future, apparently. Yeah, leave out the please. It just effectively passes this to my event, saying, act on the command that's been typed in, and I'm going to give you the conversation ID. Now, the conversation ID is a magic number that uniquely identifies this conversation. And the text the user's typed is this guy. And so my event just says, okay, user blah, 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 has typed blah, 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 blah. And my activity manages the state of the event based on those 2 messages. And then when this adaptive card comes back, I render it in the destination, and that's it. We get our messages in and we start building these adaptive card beasties. And I originally had the robot just sending back text messages and getting the user to type things in. And so I had the chatbot, you'd type forward and the robot would move forward, and my web service would just take the word forward, convert it into a robot move command and push it down to MQTT. So it's quite simple to do. But what I found was that people playing with the thing with a phone which has got buttons and whatnot on it wanted to use buttons instead. So I began to play with these things because, like I said, they are the future and cool and trendy and stuff like that. So yes, I build my reply. If you want to have a look, go to adaptivecards.io and they're just a lump of JSON which describes a particular message, and that gets rendered by the receiver in the manner they see fit. It's actually quite simple. And I wanted to use them with the chatbot because it let me do things in a fairly platform device independent way. So this is the one fiddly thing I had to find. It's a bit of a, if you work on the bleeding edge, like right on a bleeding edge, like I tend to do, you find things that are kind of hard to sort of, I wanted to take my adaptive card and turn it into a message that would be sent down the chatbot. And after a bit of diggery, I found this method, which takes my adaptive card and a name and the context, wraps an attachment around it, and then sends it back out. So pro tip, if you want to actually send adaptive card out of chatbots, you'll find this method terribly useful because otherwise I don't think it'll work. But in terms of actually building the adaptive text messages, it's actually very simple because you have a container object, your adaptive card, and what happens is that you actually just take the, you make yourself one of these guys, and you can then add things to it. And what these two statements do is they take my card, make a big shiny one, and then they add Hull Pixelbot at, and then the event name, and that gives me that message, and then enter the event password, goes in there like that. So this is actually a screenshot of what gets rendered inside the endpoint when you view it. So that's it, nothing particularly magical there. a little bit of C#. You don't have to use C#. If you want to go on to the website I mentioned earlier, there's actually a really nice interface where you can play around with the JSON and watch it rendered into cards. So if you've got your favorite way of making JSON whatevers, then you can just use that to drop the cards out and away you go. So you don't have to do this, you can just make the JSON directly, but I'm using this because it made it easiest for me. Now, what I wanted to do was have a way in which you could actually put buttons up. Like I said, I like the idea of buttons, forward, back, right or left, simple commands for our robot. So there's a mechanism called adaptive submit action, and that's kind of cute. You just give it two things. You give it the thing you want to see on the screen, which is in this case I have a list of actions, forward, back, right and left, and I want to just sort of push those out there. So I give it the name forward on the screen, and because it makes it easier for my code, I use the same string round the back as the message which gets pushed back. I've got, when you play with this, and I'm hoping a couple of folk will have a go at it towards the end, then what you'll find is that you can answer quiz questions, and the questions come up and you hit the answer that you want, and in that case the mapping is between the answer and the numbers 1, 2 or 3, which I then use to actually decode inside the program to figure out what the message actually means. So this is quite nice, because what happens is that the user sees this pop up, they hit the button, and then the data gets sent back as if they'd typed it. So you don't actually lose anything from your text interface. You can type the robot commands in by hand or other commands underneath if you want to. But if you actually want to just give them a way of getting a haircut Monday, Tuesday, Wednesday, Thursday, very easy to do. So I quite like that. And yeah, there are some there are some foibles. Like I said, I was very conscious of the fact I was on the bleeding edge with this. According to the Microsoft help files, there's a statement that's not going to end well. It's supposed to work in the browser and with the it works with the web client and also in the emulator. But I couldn't get it to work in the web client at all. That went really badly. But you can make a thing called a direct line channel, which pushes the messages back to a process running in the browser, a lump of JavaScript, which they supply for you to play with. And doing it that way, it seems to work okay. It might work with Skype. I haven't tried it yet. I should probably have put that address up for folk here to open up Skype and see if they can hit the robot through Skype. The issue with Skype is that it used to be the case that if you put a chatbot up there, before you could put it in the directory of chatbots that Skype manages, it had to be approved. And I haven't put my robot through the approval. It's not really a serious product just yet. But it knows it's me that made it, so I can always see it on Skype. It always works for Rob, but I'd be intrigued to know if they've changed the way that works going forward. So I might put the URL up and see if folk can see that. But I find this kind of interesting, because it does mean that you could make things that interact with your customers through the channels they normally use, which is cute. There's even a version of the chatbot that you can bind an endpoint to a mail address. So I'd love to have someone steering my robot around using mail message. That would be kind of cool. I'm
very sorry, Rob.
That's okay. You're not leaving, are you?
Yes, I've had enough.
Okay. I used to do, when I was lecturing, sometimes a student would say, I've got to leave your lecture early, Rob. I'm ever so sorry. I've got to leave at 10:02. I've got a doctor's appointment. And I'd say, okay, that's fine. Would you mind, when you get up, stand up, shout, I just can't take this anymore, bang the desk and storm out. Please do that. And none of them ever did. It's really sad. It's unfortunate. The other one which I used to like was when someone comes in late, as they walk through the door, you say, and that's the most important part of the course and will be in the exam. Now we're going to move on to... These are the things I had to do to make it work. And I'll put the code out, so if you want to actually make it work the way that Robert did it, then that's absolutely fine. But I did have these issues, and I'm hoping they'll be fixed going forward. They seem to be quite active. New releases keep coming up quite a lot. And so what I did was because just driving the robot seemed a bit boring, the program, the game, actually asks you a question. The name of Ed Sheeran's new album is divide, multiply, or plus equals. And you click the one you want, and then it goes on there. Whether you really want to admit knowing what Ed Sheeran's albums are called is a matter for your own personal, personal demons, but that's the way it kind of works. And I had to play with this. It's proved quite popular. I've done it once or twice, and it's quite nice. So what we can do now is I actually have got some 3D printed cheese carriers, because we did say we were talking about carrying cheese in the thing. So I'll take a couple of robots and I'll put them on here. I'll turn everybody else off. So after that should mean that. Oh, the way the MQTT works, fun fact, every 19 seconds or so, the MQTT server in the Wemos sends a keep alive message to the host to say, I'm still here and I'm not dead yet. So the idea is that when these things are awake, you can enumerate them. So I can find out how many servers I've got live, and I can find out what's out there. And so what the quiz does is when someone joins the quiz, we can then find out if they have a robot they can use. And with a bit of luck, my cheese carriers will fit on the top of the robot, because it's important that we get this bit right. 3D printing is kind of fun. Anyone here got a 3D printer? Oh, they're a giggle. They really are. The thing about 3D printers now is that, I know you've got the same one as mine. Yes. After a while, you have no feeling. Barbecues are much easier, because you can pick things off the heart. It's not quite warm, you put it back. You have no feeling in your fingers for temperature whatsoever. It's great, because you've reassembled the hot end, because you can't assemble it when it's cold because it doesn't tighten up properly. Yeah, great fun. So put the cheese in. You see, there we go. Now we can. Say again?
Don't forget the acetone as well.
Oh yes, if you put.
You cook your fingers and then burn the skin off it.
You put the acetone on the bed when it's still hot, and it goes wonderful. Yes, high as a kite. No, it's fun. Anyway, I digress. So what we've got now? We've got a cheese carrying race. We've got. If I need two contestants, and I'm going to go on here. And I'm just going to go into the right. Come on, mouse, do your thing, and we'll see if we can get two people to control the HPB host. And I'm going to log in using the super secret password, which is, of course, yeah, in we go. So now I can now open it up. I can now set the event running. And so what can happen now is if people get in quick, someone's got Crystal Maisie. Is anyone going to get to the one? There you go, someone's got red tag. Okay, so now, right, start answering. Well, this is a bit boring. I'll put a couple of roadblocks in the way. Okay, so you have to go around those guys as well. So give your robot commands and try and get to the end. Or you could just sit there. I don't mind either way. Right. Have you pressed any move buttons yet, anybody? Have you got people controlling these? Oh. What's happening there? That's doing things. Ooh. Have I got problems with my robots? Might well be. What it might be, there you go, Maisie's off. So the idea is to get past the robots and you won the cheese. But I'm not sure how this is going. One of the problems I do have, is that if the battery gets a bit tired, then making the robots move doesn't work too well. Let's just have a look. So we have got red. Oh, are we moving? Oh, good. What's happening to the one? I'll just make it a bit easier. There you go. Is it working? I would suggest that way's not going to end well. Yeah. Who's driving Crystal Maisie? Badly. You can send it colours as well. I think we have we may have I leave them on all day, then the battery goes flat. So it may be that we have battery issues, for which I apologise. You have seen robots carry cheese, so as far as I'm concerned, my conscience is clear.
They're now battling for cheese.
They're now battling for cheese. But I'll just take a picture, because I can put whatever caption I like on the picture. So I should do that. There you go. And everyone will look really as if they're enjoying themselves. But we'll leave that running, because we could be here all week, it would appear. I'm really kind of hoping that, here we go. I'm hoping that some of the things I've shown you have actually struck a chord somewhere and got you thinking maybe I could have a go with that. At the very least, start looking at the embedded stuff and the IoT bits and pieces, because I find it completely intriguing that you can get what in my day was an unfeasibly large amount of processing power and actually stick it on a thing for £2.50. The MQTT side, if you want to use a Raspberry Pi as the back end and put a server in your house, there's some very nice instrumentation stuff that will hang off that. You can do all kinds of things. The tool called Node-RED that's worth a look, which will do some very nice graphing and whatnot of things. Or MQTT talking to Azure Hub is very easy to do. Chatbots are nice for making UI for various different services. And they're basically web services, which are, again, very easy to code against. And in terms of pushing things down from the cloud into your robot, that's easy to do as well. That's kind of like where I hit my endpoint. So yeah, that's about right. The Hull Pixelbot project is always looking for people to do daft things with the robots and build them and play with them and whatnot. And so if you want to come along and take a look at that, hullpixelbot.com is the domain to head for. But thank you. I hope you found it useful and interesting and enjoyable and whatnot. And